All right, guys, welcome back to the channel. And whether you're on TikTok, Instagram, Facebook, YouTube, I'm going to say channel, like YouTube channel, but we get a lot of viewers off TikTok, so thank you for that. And I'm always up for comments, healthy discussion, criticism, all that. Just no serious uh, putting people down, things like that. Everybody has a difference of opinion, and a good example is whether you should frame these on 16 4 centers. I think I want to frame them on 16 centers. If you guys want to frame on 24 centers, I think you can make an argument both ways, and that's perfectly fine. If I go in there and mount a TV or put on heavy shelves, I want predictability on 16 centers, and that gives me that, and it also takes the waviness out of the OSB or sheetrock or shiplap. And 15 additional studs or whatever it comes out to in a 20-foot container when the customer's spending 12, 15, $18,000. 15 studs at $3 a piece to go 24 centers makes no sense to me. I'm not going to cut that corner, but I understand it's not structural. You could run 24 centers. I totally get it. So a lot of these things are pretty nuanced, and there's not always one right answer. But I'm going to say, in my opinion, that's the right answer. And so that's kind of where I'm at. All right. And so on the not only one right answer subject, cutting out holes. So we got an 8-foot garage door going here, 36-inch walk door going here. We use a thin cut to cut these about a 16th of an inch from our frame. If we're bumping on a high spot here and there, we're going to trim that back. Never cut a container bigger than needed because you're going to be welding it back. You're going to have gaps. It's absolutely terrible. On your horizontals, you've got to get eye level because the corrugation will throw you off. I see everybody, the cutting wheel deflects up, and if you're sitting down here with your eye level and you're cutting, you're going to cut high on your inners and you're going to cut low on your outers. You got to get eye level and keep that cutter horizontal. What we use is this DeWalt 60 volt. It gives you the correct RPM. I think it's like 12,000 RPM and a 0.045 inch cutting wheel. We can cut, this wheel probably did that door and that garage door both, and this wheel's about 50 cents. By the time you drag a plasma cutter over here, we've already got a door cut out and we're already halfway through the garage door, and the plasma cutter doesn't like the paint, so you need to score it for the plasma cutter. Plasma cutter is not going to give you a straight line, and so the plasma cutter just doesn't work. Saw doesn't work, concrete saw doesn't work. We've tried everything. The thin 6 to 7 inch cutting wheel is the ticket. Just wear safety glasses and or a face shield. So mark your lines on the money in a little bit where you think they're going to be, whatever you need to do. Just do not cut the hole bigger than needed. You can always trim back, but we like a 16th inch gap all the way around. All right, so we'll come in here and then we'll stitch weld this walk door in. We'll stitch weld the garage door frame in. And if we got an 8-foot wide garage door, we're typically going to come in at like 7 foot, 11.5 wide, give us a little 1/4 inch on each side so we're not exposing the edges of the garage door, and we got room for seals and all of that. So that's how we do it. You can grind this here down flat, or you can leave bits of corrugation. It doesn't really matter. On a walk door, you don't really have to grind it flat because you're putting a threshold down, but if your threshold is bumping your door, doesn't leave enough room for your seal, you're going to need to grind it down. So you can start with cutting the corrugation right above the weld, which is the thin part, and then grind it back later. Just don't try to cut through the weld with your skinny wheel. You're going to be gouging the metal down here and things like that. So depending on the height of your door frame and your threshold and your seal, generally we leave about 1 inch to 1.5 inch leg on each side of the door, and that compensates for the seal and the threshold. But obviously the corrugation weld is about 1/4 inch, so you got to figure all that out. On the garage doors, like I said, we come in a little bit smaller than the garage door, And on standard height and high cube containers, you're generally limited to a 7-foot tall garage door because you don't have the kickback. So you can go 8 foot on a high cube container, but a container is 8 feet wide. So you don't have the kickback for the garage door to go because you need a little bit of spring at the back. So about 7.5 feet is as tall as you can get on a high cube and 7 foot on a standard height. So here's a high cube. I don't know if you can tell, here's a standard height, here's a high cube. So this foot taller. So you can get about a 7.5 foot tall door in a high cube, maybe 7.7, something like that. But you don't have the space to go back unless you're cutting the walls out of them and making a double container. All right, on to this another office one here last week. They're gone. On to the customers. They were happy. So OSB again. The reason we don't use sheetrock is because it's labor intensive. It's dirty, takes a bunch of time, and industrial application. You're going to dent it. Put holes in it, it's just not that durable. We put a nice primer, nice paint on the OSB. OSB is the way to go for a budget or industrial office build, in my opinion. Again, there's not a right answer to everything. And then for something a little bit nicer, you go shiplap. But there's not a situation where we go sheetrock because it flexes a little bit, it can crack, it's labor intensive. So I just don't like it. All right, on the windows, we've got a 2x3 inch window frame that the window goes into, and then we're going to case up to the window at the frame and hide that frame generally, because that frame, if you got like a slate gray or black container, that frame will be hot to the touch inside. Sometimes we expose the frame and that gives it a little bit of a serviceability and things like that. And then we just case these generally with OSB and trim it with OSB. So like I said, and then this is an RAL 7035. If you go to Sherwin-Williams, you can give them those paint codes. Slate gray, for example, one of my favorite colors of container is an RAL 7015 slate gray. You can walk into Sherwin-Williams, give them that paint code, and they're going to have it in their computer, and they can mix it up for you. We use an A100 satin paint. Satin is slightly shinier than what a container is when you get it here, but when they paint them at the factory, they're satin. When they sit in the sun, they're going to fade out a little bit. So I go satin. You can put a little bit of water in it. That's going to flatten it up a hair. What I like to do around doors and windows is kind of like fade the paint out to a break in the corrugation, and that kind of hides your paint line. But you really can tell that we put that door in and then touched it up. And I like everything to look OEM factory like they did it at the factory in China. So I don't like to mess with these numbers, take them off, interfere with any of that stuff. I like it to look perfectly factory OEM style. I have been over the mini splits ad nauseum. Window unit is not going to keep up with a shipping container. Even in the summer, it may do the job, but for example, we're going to run all these 20 foot off of a 15 amp extension cord. No one needs anything other than that because they're not running like deep freezers and GPU gaming computers and all that. What a window unit forces you to do is the SEER rating, SEER, it's not efficient. So it's drawing, 8, 9, 10, 11 amps to put out the same BTU as a mini split does at 7 amps. So then you have 0 amperage left over to run lights, computers, or anything else inside the container. And what do you gain with a window unit other than a little bit of ease of install? You're going to install the mini split one time and be done. So just do it the right way. And we're going to hide those lines inside the wall. But these mini splits are so efficient that they allow us the extra 7 or 8 amps that we need to run computers, TVs, fridges, and all that other stuff off of one extension cord, which is important to a lot of my customers. Where the window unit really falls short is the winter. They do not have the same heating capacity BTU-wise at the same amperage as a mini split. It's not even close. I know they have new technology, but it's still not even close with a mini split. All right, spray foam. All right, spray foam insulation. You can see here a container is corrugated. The outer corrugation is about 1.5 inches out from the inner corrugation. About 1.5 inches variation there. We're 2.5 inches on the inner corrugation. That means we're about 3.5, almost 4 inches on the outer corrugation. This is extremely good coverage. Closed cell spray foam provides R14 at 2 inches. Beyond that, the gains are very minimal. And we don't use fiberglass for various reasons. Covered that in a lot of videos. Moisture, you can't do the floor, it's cheap, it's just not the right way to do it. Like I said, if you're spending $12, $15, $20,000 on a container office or home, the fiberglass insulation corner is not one I'm going to cut. And a foam board is just going to eliminate space inside because you need to do it behind the framing. But you have to do the floor of a container with insulation, and that's all it comes down to. So this container here, we just have to wire it. It's ready to go. If you guys want like 20-foot portable office, we usually have these. We can spec them out any way you want. We usually do conduit, electrical on the inside. You can also do Romex inside the walls, a little cheaper. We like the flexibility of conduit. And then one last thing I'll show you for this week, and we're going to wrap it up. We painted this container black. Lighter color, so it's a little cooler in the summer. There's your vanity, shiplap, white. We've got this fan to pull heat or cool from the other unit with the mini split over to this side, and then we're installing the exhaust fan now. And then you have your ADA rails. These are located at 32 inches above the floor, 48-inch rail, 36-inch rail. That's your ADA requirements. There's no certain specification for the size of an ADA bathroom, but it's approximately 8x8 or 8x10. So you just have to check with your architect or local building code on that. And then to save power, we went with a 2.5 gallon tanked electric water heater. This pulls 1500 watts, running it all out, so we can still run this off of a 120 volt, 30 amp cord. If you do an on-demand electric water heater, you're going to be pulling 30 amps at 120 volts. So if you got room for a little tanked heater, go that route. And all they have in here is 2 sinks, so this is going to work out really great. And so that should be it. And then we got our Amazon faucets here. The plumbing on site is going to be trenched to hook up the toilets and the water supply. And then you can see here, we spent a lot of time getting the caulk just right. So like I said, questions, comments, we welcome them. Just be respectful, and if you guys see anything or have ideas that I haven't covered, let me know. Thanks for watching.